Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. Now, a couple important things. First of all, hopefully you all know Thursday is Thanksgiving, and if I forget Wednesday, I better do it now. I hope you all have a happy and, more importantly, safe Thanksgiving. Hope you're not traveling anywhere and not putting yourself or anybody else at risk. Unfortunately, if you've seen the news, there are a lot of Americans traveling, which is not good, but that's another story. Couple things. Officially, ECC closes at 5 p.m. So that means on Wednesday, I will have class. If you can't make it, I will be posting the video. Now, because I had to move my COD class that meets Tuesday and Thursday and is a net class, this morning I had a lecture, which I normally don't do. There might be a delay until Wednesday morning at the latest where I get the video for today's lecture posted in YouTube, but I will get it there. Normally I try and do it the same day, but I also have to do that one. So upload in YouTube is, how should I say, as slow as molasses, and it's more to YouTube, not my internet connection. Speaking about internet connection, if I lose internet connection, hang in there, it'll come back, hopefully. It happened twice this morning, and I have, wow, I've lost connection more times in the last 2 weeks than I've done in the last 10 years. I don't know if it's just everybody using it, their equipment's getting old, or they hired someone who's a total idiot. Whatever, same thing. Yeah, I did get back on Zoom. Now, I didn't have a chance to look at it, and let me do it right now. Hang in there for a second. Huh. Getting some weird messages. Huh. Well, sorry about that. Something strange going on my computer. And anyways, I'm not sure if it's next week or the week after is test number 4. I think it's next week. I should have looked at the syllabus. For some reason, it's today Friday the 13th. I've been having this weird luck today with computers and everything. But anyways, if test number 4 is next week, by Sunday at the latest, I will have online and also send out email the points breakdown for test number 4, which will cover fats and oils, otherwise known as lipids, and carbohydrates. All right, another thing, let me remind you, if you're planning on doing the extra credit project, which is coming up soon, don't forget, you can email me and I'll check it before you hand it in, so you can get 10, yes, 10 bonus points. The last thing, because I lost internet this morning, I didn't have a chance to do it, and with my schedule, by Wednesday morning at the latest, hopefully earlier, like sometime tomorrow afternoon, because tomorrow I'm going to be totally swamped in the morning, I will have posted all your current lab grades. If you're missing a lab grade, that means either I can't open it up or you didn't hand it in because of my back problems and COVID-19. Dr. White, don't be telling anybody. I'm going to be nice. And I'm not going to enforce the points limit or penalties. I should have been on a number of people who are, how should I say this, missing labs. But if you can't get a lab because the assignment area is closed, email me and I'll send it to you, and you can send it back to me finished with by email. If you haven't done a lab, go look at the YouTube videos. Remember, I have my YouTube video set up, date stamp. It has year, then month, then date, so you can find out which YouTube video is for each lab. And you can see, again, my introduction that will help you do the lab. All right, today I promise we go through the fats and oils, otherwise known as the lipids problem set. Let's do that first. And send it a semester. And let me check. All right, let's do something. Can everybody see lipids practice problem on the screen? Thank you. All right, Dr. White's getting lazy. What's a lipid? Something that comes from an animal or plant or human, something that was live, that's not soluble in water and soluble in nonpolar solvents, like alkanes or gasoline. Name one type of lipid. It can be a fat, it can be an oil, or steroids, a lipid. This is something you should know. What's the difference between a fat and an oil? A fat is a solid or semi-solid at room temperature. An oil is a liquid at room temperature. What's yellow grease? You should know that's pig's fat. Let's see if I have the next one. Nope, I don't. I can't write on this one, so hang in there. Hold on, this isn't doing what I want. All right, a little extra stuff. What's tallow? I'll give you 8.7 seconds. 1, 2, 3, 4, 5, 6, 7, 8. Bonus time. It's beef fat. What's white grease? You should know. I'll give you 8 seconds. Give you bonus time. 9, 10, 11. Time's up. And you should know that also is a type of pig's fat. Not that I'll be on the test, but if you know where to look, and I do, Wall Street Journal on Friday, you can find the price of tallow, white grease, and yellow grease every Friday in the Wall Street Journal, because they're that important. By the way, tallow is cheaper, not cheaper, white grease and yellow grease are always cheaper by about 2 or 3 cents a pound to tallow. When if you're buying 100 million pounds a year, that adds up. I worked for a company, we did. All right. Next one, give the organic product or products for the following reaction. What do we have here? Well, this is sort of a pseudo fat, and you're reacting with sodium hydroxide and base. Remember, what functional group is in this triglyceride? 3 esters. Esters, sodium hydroxide, and water. You get back the alcohol and the carboxylate anion of the carboxylic acid you would have used to make that ester. First ester, you get this alcohol plus this carboxylate. Second ester, you get this alcohol plus this carboxylate. Third ester, you get this alcohol plus this carboxylate. Next one, same triglyceride. If we react it with acid and water, by the way, base or acid and water, and base and water will not react with a double bond. If you see up here, it's still there in this carboxylate anion. Now here we have an ester, triglyceride, 3 esters, reacting with acid and water. What happens? General reaction, ester, acid, and water. You get back the alcohol and the carboxylic acid you would have used to make that ester. First ester, get this alcohol plus this carboxylic acid. Again, the double bond is not affected. It comes along for the ride. Second ester, you get this alcohol plus, here's my R, and I get this carboxylic acid. And the third ester, I get this alcohol, and you get glycerin just like you got before, and you get this carboxylic acid. Now, react this ester with hydrogen and catalyst. Oh, guess what? An ester will not react with hydrogen and catalyst. I'll say this again. An ester will not react with hydrogen and catalyst, but a double bond will, as you learned for test number 1. Double bond, hydrogen catalyst break the pi bond, and each carbon of the double bond gets a hydrogen. And if you notice, this all stays the same. The only thing that changes is this. And notice on the, I even said, look, you break the pi bond, and each carbon gets a hydrogen. And here I just did a different catalyst, same as C. Now, let's move on to E. Ooh, this triglyceride with steam. Remember, steam is hot water. By heating a reaction, that's another way to make it go faster. Catalyst, adding a catalyst like acid or base will make it go faster also. Tea break. Until it's getting cold out there and having tea in the afternoon. And what happens? Steam, hot water, gives you the same products as acid hydrolysis of an ester. You get back the alcohol and the carboxylic acid you would have used to make that ester. First ester, I get this alcohol plus this carboxylic acid. Notice the double bond is still there. Second ester, I get this alcohol plus this carboxylic acid. Whoop. And the third ester, I get this alcohol, so I get glycerin plus this carboxylic acid. Now, next one, yellow grease plus acid and water. Oh no, what am I supposed to do? Well, remember for both yellow grease, white grease, and tallow, I'm using this designation where R sub S means sterile, 17 carbons, 18 plus the carbonyl, only carbon-carbon single bonds. R sub O is oleal, 17 carbons, 18 counting the carbonyl, with a double bond at C9. And finally, this again. So the general reaction is ester plus acid and water gives you a alcohol you would have used to make that ester and the carboxylic acid. Now, if you go back up here, no, says give the organic product or products. Nowhere have I ever asked this semester, never will, where you have to balance it. So let's look at the first ester. I'll get this alcohol plus stearic acid, R sub S. The second alcohol, I'll get this alcohol, the second alcohol on glycerin, plus here, R sub O will give me oleic acid. And finally, the third ester will give me this alcohol, so I get glycerin, and I'll get more stearic acid. Now, if you wanted to put a 2 here or rewrite it, you can, but Dr. White's a lazy organic chemist, and we're lazy, so I don't. Now, listen carefully. If I ask on a test, draw the structure of stearic or oleic acid, do not use this abbreviation. However, in a reaction, if I give this to you, you can use it. I'll say that again. On a test, if I ask, draw the structure of stearic or oleic acid, then you have to draw all the carbons. If I give it to you like this or like this, then you can use the abbreviation. And notice if you take tallow and acid and water, you get to start with the same thing, so you should get the same product. And white grease, again, I'm using this designation, and you get the same as F up here, glycerin, stearic, and oleic acid. Now, take white grease, yellow grease, or tallow, react it with steam, you get the alcohol and the carboxylic acid you would have used to make that ester, which instead of acid and water, you have steam. This would be steam, not acid, and I get these glycerin plus stearic and oleic acid. And if we do base hydrolysis of yellow grease, we get this general reaction, ester plus sodium hydroxide and water, alcohol plus the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol, I didn't mention it, that you would have used to make that ester. And what yellow grease, white grease, or tallow, I'm using this structure, and you'll get first ester, this alcohol, plus this carboxylate anion, R sub S, sodium stearate. This ester gives this alcohol plus sodium oleate, and this one right here gives this alcohol, but this will also give sodium stearate, so you get 3 products. Even though you get 2 of these, they're 3 different products. And if you take white grease or tallow, you're going to get the same here, because we're using, for my class, and in real life it's true, essentially identical. You start here and you get the same products. Now, I will have at least 1 or 2 give the starting material for the following reaction, and here, give the starting material for the following. You could draw it or name it. What do you react with sodium hydroxide and water to get glycerin, sodium oleate, that's what the R sub O, and sodium stearate. And if you look up here, it could be yellow grease, white grease, or tallow. Now, I got something hidden down here that I didn't talk about. So what's the surfactant? And a surfactant is something with a polar head and nonpolar tail. Now they actually say a long, and this is important, long non-polar tail and a polar head. Now, something I didn't have on the problem set, so Dr. White's gonna, hi Alondra, gonna help share with you And sometimes I'll put excess if I'm a lazy organic chemist, like I feel today. I won't. And the question is, what's the organic product or products for the following reaction? Have fun. For those who came in late, I mentioned earlier, if you have any labs that you haven't handed in, make sure you get them in, please. If you need help, come to my office hour. Oh, I don't know if I mentioned it earlier or not, but I'll mention it again. Because COD officially closes at 5 p.m. Wednesday, I can't have my office hour on Wednesday because the school's closed. Therefore, tomorrow night, also tonight, I'll have my normal office hour, but tomorrow night, I will have a Tuesday special office hour, same time, 6 to 7:15 on the same Zoom link. And if you need help, come on by. Or if you just want to say hello to Dr. White, stop by. All right, let's do this. Now, let me remind you, R-sub-O means there's a double bond at C9, carbon 9. And if you add hydrogen and a catalyst, which can be nickel, in real life, you don't use palladium or platinum because this is industrial and those are too expensive. You break the pi bond and each carbon gets it. So what that really means is R-sub-O becomes R-sub-S, which would be 17 plus this, 18 carbons with no double bond. You do not break, an ester does not react with hydrogen. And this R-sub-O becomes R-sub-S. The R-sub-S doesn't react. And the final R-sub-O, the ester is not broken, becomes R-sub-S. And this is how they make hydrogenated fats and oils that they use in various things like foods, which are bad for your heart, but help imitate butter. Now, there's two other questions I should have put on the, hold on one second while I do something. All right. Something's going on with my computer. It's running out of memory. Shouldn't. But anyways, let's do this. Hold on one second. Let me check something real quick. I'm closing some programs I don't need now. Give me more memory. Hang in there. All right, let's see if it likes me now. Let's try something else. All right, hold on, I'm going to do something else. Sorry about that. Anybody know if this is Friday the 13th? The computer gods have been mad at me all day. Let me open up some stuff. Aren't you glad I'm a power user so I know how to fix problems slowly? All right, we're back to up and all right. And can everybody see the whiteboard? Thank you. And I'll let you do this first. Draw the structure for stearic acid and oleic acid. Go. And when you're done, give me a thumbs up. And I'll give everybody time to finish. 5, 4, 3, 2, 1. Time's up. Put down your pens and pencils, hand in your computer. Oh, I was just practicing when I'm in the classroom. All right, stearic acid. It's a saturated carboxylic acid. Saturated means only has carbon-carbon single bonds. It has 18 carbons, and it's a carboxylic acid. If you notice, 1 plus 17 plus 1 is 18 carbons. Now, oleic acid also has 18 carbons, but it's a monounsaturated carboxylic acid, which means it has one double bond at C9. If you notice 1 plus 7 is 8, that makes this C9, carbon number 9. And that's the structure for oleic acid. And Dr. White, for a number of years when I worked at one company called Chemicals, our main products were stearic acid, oleic acid, and glycerin. Now, I won't ask on a test, but just to remind you. And we talked about this when I went over alcohols, but to remind you, we made glycerin. And the company made about 100 million pounds a year of each one of those, give or take a few million pounds, depending. We made some other stuff, but those are our main things. One of the things I did, which they still sell, is I developed 2 new grades of oleic acid, and I also helped improve the purity of both oleic and stearic acid. It was an interesting time working for them. Unfortunately, Dr. White got in a lot of trouble. How did I get in trouble? Well, doing what I always do, and that's doing things nobody else can do, and people above me get upset. Don't ask me why. They're paying me to do the job, but at that company, when I got hired, part of the way they enticed me to work for them is, besides being the quality control manager, I would be the laboratory manager. Well, I had to set up and develop my own lab staff. And for a while, I only had one other, actually it was a chemical engineer, but when another company, before he got his chem eng degree, Byron had been a technician working for me. He was a damn sharp person. And I hired him to come work with me as a chemist, quote, chem eng. And the two of us created things and did things, and I did things that that company had a research center in the Netherlands in Gouda, otherwise known as Gouda. They had about 150 people there, and we did things they hadn't been able to do. And the research director there got awful upset because here he had all these PhDs and everything, and here I was pulling off things that was making the company a lot of money. And the president of the company asked the research director, how come you guys aren't doing what Dr. White's doing? And that got him real mad, not the president, but the research director mad at me. And that's not good. And I found out that. But they hired me to do a job, and I did. And unfortunately, the higher up you get in corporations, the more like little kids people act. All right. One other more important thing I'd like, let's try something. Oh, good. This is now working. All right. Now, something you should know, and I didn't have it in the problem set, so I'm going to go through it now. Of all the things I'm teaching you this semester, this is high up on super, super important. I better be subtle. Am I subtle enough? How does soap work? You should know the structure of soap. Soap has a long non-polar tail and a polar head. The important thing when it comes to how does soap work, and if I were in a classroom in ECC, I'd write this as large as I can. The important part of this puzzle, how does soap work, is like dissolves like. And what that means is things that are polar are soluble in polar things, things that are nonpolar are soluble in nonpolar things. And if you mix the two together, they're not soluble. Well, you should know water is polar. Dirt and grease are nonpolar. There are other things that are polar and nonpolar, but for this is all you need to know. And if we take a piece of dirt and look at it, water will look at dirt and say, oh, you're nonpolar, I'm polar, stay away from me. And they don't do anything together. But if you have soap in the water, like you take your hands, water, soap, and you go like this, what happens? Well, the soap, which has a nonpolar tail, says, oh, you're nonpolar dirt, my tail is nonpolar. Well, I'm going to line up like this. Well, it turns out a lot of molecules of soap do that. Remember, the molecular weight of soap in grams is 1 mole, and that's Avogadro's number, 6.02 times 10 to the 23rd molecules. So you got a lot, and this totally surrounds the dirt molecule to form a micelle. And you should know what a micelle is and how to draw it. And a micelle has all the polar heads on the outside, and the inside hidden away is the dirt molecule. And now water looks at the micelle and says, oh, I'm polar, micelle, you're polar, let's go down the drain together. And that's how soap works. And let's go through it again. Soap, how does soap work? And by the way, really know this, and I mean it, really. That way, if somebody comes up to you on the street and taps on the shoulder and asks you, do you know how soap works? You can tell them. Seriously, this is important. One of the important things I'll teach you this semester. You should know soap has a nonpolar tail and a polar head, and it looks like this. And the most important thing, how soap works, is like dissolves like. And that means things that are polar are insoluble in polar things, things that are nonpolar are soluble in nonpolar things. Now, water is polar, dirt and grease are nonpolar. Therefore, if you mix water and dirt together, nothing happens because light dissolves light. But if you have soap present, it forms a micelle, and you should know how to draw the structure of a micelle, what a micelle is. And now water looks at the micelle and says, oh, micelle, you're polar, I'm polar, let's go down the drain together. And the dirt particle in the center of the micelle is stuck in the middle there and goes down too. And that's how you clean your hands. That's how you clean your cooking utensils and dishes and plates. And that's how you do your laundry. And if you wash your car, that's how you wash your car. It works the same. The only difference is what's used for soap. And this won't be on a test, but this carboxylate anion, R sub T means tallow, that's a mixture of oleo and sterol, which comes from beef fat, which is tallow, yellow grease, or white grease makes this, is in your bar soap. And if you have a detergent for your laundry, this won't be on a test, but I thought you'd like to know. This is called LAS, linear alkyl sulfonate. This is sulfonate anion. And here we have nonpolar tail, and polar head. And this is your detergent. And if you use all Tide or whatever, this is the key molecule in all of them. Now they put other additives. Now I personally have been for many decades because I like it. I use all. I never was big on Tide, and I think it was also because my mother used all. What the heck? It works well, and I like it. Now, if you look at bar soap, this is about 17 carbons, so this would be a nonpolar tail. And this part is your polar head. And they all form micelles. How many of you have heard of the product called micellar water? And it was a couple of years ago in Chem 170, a student came into class, and at the end of class, she said, "Can I talk to you, Dr. White?" I said, "Always." And she said, "Have you seen this?" And she brought an ad from a magazine for micellar water, which has been told a very good cleansing product, especially for makeup. Oh no, I forgot to put my makeup on. Don't look. Nope, I didn't do my lips either. Shucks. But anyways, I looked into it, and guess what? It's a misnomer. But most Americans, most women who buy that don't know. Guess what? There are no micelles in micellar water. It forms the micelles when you use it to clean your face. And let's see something real quick. I'm trying to see if I can find. All right, everybody see Google on there on the screen? Thank you. This is, I forgot whose brand of micellar water. And here are some of the key ingredients. And the most important thing, surfactant, hexylene glycol, no, but this disodium cocoa amphodiacetate is a very long non-polar tail and polar head. And the other stuff helps solubilize it. I have no idea what this is. Let's find out. I think I know what it is, but it's a non-ionic polymer, which sort of helps. It's more something to help your skin feel good. And one of the important things about taking my class is you now understand some of this stuff, and you can look it up and find out what's going on in your daily life. Speaking about what's going on in your daily life, I'm going to take a break. We'll start a minute earlier because before I move on to new stuff, I think it's a good time to take a break. I'll see you at 1:55. That's when the big hand is on the 11 of your clock. If you have a digital clock, that's 1:55. I'll see you in 5 minutes. I'm going to go stretch. Time to start again. All right, before we leave fats and oils, there's one more thing I would like to talk about, and that is you should know how to describe with words and a general reaction how you digest fats and oils. You should know how to describe with words and a general reaction what happens in your stomach when you eat a fat or oil or any food that had a fat or oil. If you had a hamburger for lunch, it had fat in it. If you had salad dressing, it had oil in it. Now, quick reminder, what's in your stomach? One of the great miracles of life in my mind is my stomach or my body and your body all have cells that make hydrochloric acid, H+. And if you drink like I do, and you should, water during the day, in your stomach, you have water and acid. So how do you do what I just asked you to do? First of all, how do you describe when you eat a fat or oil? It's acid hydrolysis. And what functional group is in a fat or oil? An ester. So how do you describe with words what happens in your stomach when you eat a fat or oil? It's acid hydrolysis of an ester. And this is an important thing I'd like you to leave my class knowing. And what's the general reaction? You learn for test number 3. Take an ester. I'll write it this way. You could also write it the other way, where this is first, but doesn't matter which way you do it. And you get back the carboxylic acid plus the alcohol you would have used to make that ester. So how do you describe with words and a general reaction when you eat a fat or oil? First of all, with words. It's acid hydrolysis. Why? Because there's acid and water in your stomach. And what functional group you should know is in a fat or oil? The key one is ester. And acid and water react with an ester to give back the carboxylic acid and the alcohol you would have used to make that ester. This is something you should know. Ooh, it even says it on the screen, so it must be true. You know, things on your monitor never are lies. And I got a bridge downtown Chicago I can sell you cheap too. That's an old joke when you were trying to be facetious about something that was a lie. Tea break. All right, any questions on fats or oils? Ooh, I forgot one other thing. Bad Dr. White, bad doctor. Everybody know what this is? Last semester, I had a student from China. I had no idea what this meant. And I taught her. Then she didn't know what this meant. Everybody knows what that means. So he must be crazy. And so I taught her a lot of things besides chemistry. Very good student, very nice person. All right, I just lost my train of thought. It happens when you get old. Well, it'll come back to me. It came back to me. You should know. Well, I'm giving you too many hints today. I got to cut back on these. Before you know it, you'll learn all this stuff. You should know how to draw the ring skeleton for a steroid. And it starts out, and let me give myself some more room here, a 6-membered ring, then fused right next door to the right, another 6-membered ring, then at 12 o'clock high here on the second, a fused ring, 6-membered ring here, and then right next door here and here is a fused 5-membered ring. And you should know how to draw the ring skeleton for a steroid. And all steroids, as I taught you last week or the week before, I think it was last week we covered this, have this ring skeleton. And whether it's your hormones for male or female or other general for everybody, actually male have female hormones and female have male hormones, just the amount is different. Hopefully, unless you don't want a beard or do want a beard. But you should know how to draw this 4 ring. And this won't be on a test. It's called the A ring, B, C ring, and D ring. 1, 2, 3, 4 rings. They're all fused together. And every hormone, which are steroids, have this ring system. All right, now I can ask, I almost lost my train of thought. I'm gonna have to go like this so it doesn't ooze out of my ears. But anyways, oh, that was an awful joke, sorry. But any questions on fats and oils before we get back to carbohydrates? Going once, twice? Did anybody put their right hand up to a mirror and see the enantiomer of your right hand, non-superimposable mirror image, your left hand? Got to work on you people. Huh. All right, everybody see chapter 18? That should be 16. How did that get? The number virus just hit my computer. Changed the number. All right. Just a quick thing, remember sugar is a monodisaccharide. Here is glucose, which is a monosaccharide. And here is fructose, which is also a monosaccharide. If you put two together, we call that a sugar. And the most important one is we call sucrose table sugar. All right, now, last week I showed you about this way cyclization can go to form the cyclic form of D-glucose. And this would be a good time to review it. For test number 2, you learned an aldehyde plus an alcohol plus acid catalyst will give you a hemiacetal or ketal. Keep your eye on the carbonyl carbon because that's where the fun is. Should ask everybody see my whiteboard? Well, I'm glad I asked. All right, now can you see it? Thank you. All right, if you take an you learn for test number 2, aldehyde or ketone when R prime is hydrogens and aldehyde, when R prime is carbons to ketone, add an alcohol and acid catalyst, and you get a hemiacetal or hemiketal. Now this is glucose, and you should be familiar with the structure, even though on a test I'll never ask you to draw the structure of glucose as a question. Now, at this carbon right here, which is C5, this hydroxyl group is this alcohol. And this carbonyl aldehyde is this carbonyl. Now, when your functional groups are in the same molecule, you don't need a catalyst. It's called intramolecular reaction. And what happens is this hydroxyl group attacks the carbonyl, just like this hydroxyl group attacks the carbonyl and forms this bond and opens it up to an alcohol. So if that happens, what I'm going to do first is whatever is not involved in the reaction, I'll rewrite. That was simple. Now, there's still a carbon here, still a hydrogen. Now, if we look at the general reaction up here, it will have a hydroxyl group, and it will be bonded to the oxygen and the alcohol. Oh, by the way, what I didn't do is this. And that oxygen is this one. And to make your life easier, we'll just have the world's longest carbon-oxygen single bond, no arrow there, and I'm done. This part is this part right here. And these are part of the HR prime is this, and these carbons our double prime, which just happens to be connected to the alcohol. If this were connected like here, and it would still be connected. So on a test, if I give you this molecule and the double-headed arrows, which is equilibrium, you should know how to draw this structure. If on a test, I give you this structure, double-headed arrows, ask what's the starting material, you should know how to do that. Now, that's for glucose. You should also know for fructose. Hold on, Dr. White always forgets the structure of fructose. He did it again. All right. Now, this is fructose. And as you just learned, Dr. White is not a carbohydrate chemist, but remember his structure. Now, this is equilibrium with its closed form. And the same general reaction applies. I take an aldehyde or ketone, in this case it's a ketone right here, and react it with an alcohol in the presence of acid. Now that's for intermolecular, where the alcohol and the aldehyde or ketone are separate molecules. You need a catalyst, the acid. If it's in the same, you don't. And you get a hemiacetal, hemiketal. Well, here's my ketone. And at C5, this last hydroxyl group right before the CH2, this one right here, is my alcohol. And once again, just like here, where the hydroxyl group attacks the carbonyl carbon, open it up to alcohol and form this oxygen carbon single bond, this hydroxyl group will attack the carbonyl carbon of the ketone. What's ever not involved in the reaction, I'll just redraw. And I did. And I tell you, the closer I get to Thanksgiving, the worse my hydrogens look. They look pretty bad. Now, this oxygen is this oxygen right here, which is bonded to the carbonyl carbon, which is now no longer a carbonyl carbon, this carbon. And that carbon, I'll have a hydroxyl group. And that's what you get, this hemi-ketal. You should know, if I give you the structure of fructose and a double-headed arrow, how to draw this hemi-ketal. If I give you this hemi-ketal, you should know how to come back that this is fructose. And we went through this before, but this is good review. And I'll probably do it again on Wednesday. Since Zoom has been playing games with it, everybody see the structure from my slides of D group fructose? Thank you. I went through how this forms this cyclic. Aren't you glad I'm not asking you to learn how to do the Hawthorne structure? The first year or two when I taught this organic chemistry, I put this on a test and not one student ever got this right. That's when I came up with my ugliest, but it helps the students, different way of writing the cyclic form. I did reductions. Remember, I talked about sorbitol. So now it's time to get something very important. Now, don't write anything down from this slide because I'll be working on the board. It says a glucoside formation from monosaccharides. Glucoside is the acetal or ketal form from a cyclic monosaccharide. The glucoside is the glycoside formed from glucose. And, this is an important one. This is for Dr. White. Remember the reaction with methanol. I better get to work. Hold on. Yep, I remembered it. Good news. Now, remember a while ago I said no new reactions? Well, I sort of fibbed just a little. Everybody know what a fib means? That's a tiny little lie. I'm going to show you a variation of a reaction you've already known, but it's not really new, but I didn't show you this variation before. Everybody see my whiteboard? Thank you. For test number 2, you learned the following reaction. If you take an aldehyde or ketone, react with not one, but 2 molecules of an alcohol acid catalyst. Keep your eye on the carbonyl carbon. That's where the fun is, and truly is. What's attached to it stays attached. And then you get not one, but 2 alcohols that form these OR on that carbonyl, and this is called a ketal or acetal. Now, here's what I didn't show you. Let's go through sort of the mechanism. Since I have 2 molecules of alcohol, I'll do the first one, and this you learned also for test number 2. Now, it turns out you can isolate these hemi-acetal, hemi-ketal. And the way I showed you a reaction, we didn't. And the second step, and this will never be on a test, is the second alcohol. Here's number 1. Here's number 2. And acid and water reacts with this to form this acetal or ketal. Notice on the oxygen, both our groups are the same. We call that symmetrical. Now, here's what I didn't teach you, but I'm going to teach you now. If I take the hemiacetal and isolate it, I can come back with a different alcohol, react it with acid and water, or acid, not acid and water, and what you get is now an unsymmetrical acetal or ketal, where the R groups on the oxygen are different. So the new reaction sorta is going from here to here with a different alcohol. And it turns out you can do that. Now, I said, remember the reaction with methanol. Oh, I remembered it. Now, let's take a look at something. We'll just do it for here is the cyclic form of glucose. And what this really is, the hemiacetal form, as you see here. Now, if I take this and react it with another alcohol, what is that like? This. Notice the only thing that will change will be this hydroxyl group. And you get that, which is what I just showed you. So here's my carbon here. Here's my hydroxyl group. And it changes to this. So whatever is unreacted won't change. The only thing that does change is this to OR triple prime. Now, why is this important? Because if this reaction didn't occur, we wouldn't have any carbohydrates like starch, wheat, rice, potatoes, the good things in life, French fries, potato chips. Dr. White loves rice too. Special basmati, I always pronounce it basmati rice. So let's take a look at this. I did remember the reaction with methanol. And the question is, what's the organic product or products for the following? Well, what do we have going on here? This is an hemiacetal. This is an alcohol. This is our triple prime. Therefore, what's not involved in the reaction I can just rewrite, and I am. And the only thing that changes is this to this. What's our triple prime? Methyl. And the carbon with the hydroxyl group is the carbon bonded to this oxygen. I'll give you time to copy that down. No, something I just forgot. I never scheduled something I should be doing. All right, everybody got a copy down yet? When you do, give me a thumbs up. All right. Before I move on, real quick thing. Oh, let's do it as a Thanksgiving special little gift from Dr. White. As you might have guessed by now, I spent a good part of my adult life working in industry, not teaching, even though I've done that for a number of years now too, because the chemical industry died in Chicago. But that's another story for another day. But because I was a senior manager, I hired a lot of people. And also I got hired at companies because I got fired for doing things that got other people jealous. They happened to actually 3 companies. The last one, I saved that company $6 million a year, and my boss's boss got scared and got rid of me because he thought I'd be getting his job soon if he didn't get rid of me. Well, that's another story. I just told it. But anyways, what I do know how to do is interview, both personally and when I interview people, what to look for. And there's certain skills that most people don't think about. Wednesday after class, and we're going to end early on Wednesday like we normally do. I would say by 2:15 we'll be done. But I'll stick around for anybody who wants to, and I'll give you some tips how to interview. Now, a couple years ago when I started this, I had a Chem 170 student. I taught how to interview. Next day, she had an interview at a hospital for a phlebotomist job because she needed organic chemistry to get her associate degree. And she walked in, used all the techniques I taught her. And true story, well, Dr. White doesn't lie, but you know that by now. She got home, her phone rang, and she'd only been home a half hour or so after the interview. And turned out the person who interviewed her, who would be the person hiring, called and said, you did such a wonderful job interviewing you. I want to offer you this position right now. I don't even have to think about it. And she got the job. Another story, student went to the University of Illinois Chicago campus for an interview to get into nursing school. And there are 3 people, I don't know, a dean and 2 professors who interviewed her. And she used the skills. And this I still, wow, how amazing. She nailed it, just like that other student nailed me and did real good. It's a tall building. She was walking out. She was about 20 feet outside the building when her cell phone rang. And she said, hello. And it was the person from the committee. Could you come back right now? And she wondered, what did I do? And she came back and asked her to sit down and said, the interview you just did, we all realized was the best interview we've ever seen from any student. We want to offer you right now a position in the nursing school, which he accepted immediately. And it worked. So I'll be doing that Wednesday after lecture and lab. And if you want to stick around, I will take it out of the video. For those of you who aren't around, and there are a couple of you, come to my office hour and I'll do it again. It doesn't take too long, about 10 minutes, but it's quite effective. All right, now let's go back. Remember, if you have, this is a hemiacetal reactor with an alcohol, you replace the hydrox group with OR, and the R triple prime is this. So give the product or products for the following reaction. I just thought about it. Boy, we are right on track. Everything's going real well. While you're doing that, I'm going to check and see if the Michigan Board of Certification did something smart or stupid. Nope, they don't have anything. Nope, nothing current. All right, looks like everybody's done. I better get to work. So, what do we have here? Oops. We have a hemiacetal where R prime is hydrogen. This carbon here is this carbon here. What do we have here? An alcohol. Aren't you glad I had you learn that fun game? Circle and name the functional group, 2 points each, which will not be on test number 4, but might come back on the final. Uh-oh, I'm giving away goodies. And this is what changes the hydroxyl group to OR triple prime. Therefore, all of this doesn't change. And because of that, I'll rewrite it. And this becomes O triple prime. What's the R triple prime? Isopropyl. Remember, the carbon with the hydroxyl group is the carbon bonded to the oxygen. Now, important thing I didn't mention, but I'll mention now. Common mistake on test number 4, students forget that bond between this carbon, this oxygen, and this carbon. If you forget that, it's not right structure. So don't forget this bond right here, this long bond between the oxygen and this carbon. It's over here too, and you don't break it. All right, listen carefully. I'm going to write something on the whiteboard. Do not copy it down. If I were in a classroom right now, I'd say I'm going to write something on the whiteboard. Don't copy it down, but it's something I need to teach you. Why not copy it down? You'll understand. Everybody see my whiteboard? Give me a thumbs up if you can. I apologize. Either my modem is going bad or the internet service is screwed up today. I think it's screwed up. Uh, I look at the clock. Let's take a 5-minute break. Come back at, let's see, 2:55, and we'll continue. I need to get up and stretch, and I'll see you in about 5. Hopefully, I'll still have internet service. And I'm going to be making a nasty phone call once I get through with this class. So I'll see you in 5 minutes. Come back, and I'll finish up where we're going. I'm back. Let's see how long before either it's my modem is dying or my internet company is messed up. I think the latter, but I might be wrong. I'll call them right after we get through today. All right, let's get back to the exciting stuff I was talking about. Now, everybody see the whiteboard with the mess on there? Okay, now what I was showing you is now the second glucose molecule, the same hydroxyl group and the same carbon that is this right here can react to form this linkage. And it's the same thing as happening down here. And now at C and D, I have this same carbon here, which is this right here. And I have this alcohol here, which is this alcohol here. And the same thing can happen again. And notice what has happened. I have glucose molecules linked together, A, B, C, and D, in this type of acetal formation. And if you notice on this D, I have the hydroxyl group on this carbon, the hemiacetal, and I could do another glucose molecule. And I could keep on going on and on and on like the Energizer Bunny. And what it really looks like is I have glucose molecules linked together by an acetal linkage. And what does this mean? Now, how many of you, when I first started this chapter and said carbohydrates, thought of bread, starch, or other things like that, rice? Well, this is how Mother Nature forms starch. Starch is a lot of glucose molecules linked together. Now, the other thing is, how many of you have heard the term cellulose? Cellulose is the material in the cell walls of plants. And if you look out your window and if you see a tree, what's holding the tree together and up is cellulose in the walls of the cells of the plant, in this case, a tree. Now, Dr. White is well beyond his knowledge of biology, because the last time I took biology was freshman year of high school, but I do know the chemistry of cellulose. I've worked with it sometime. But anyways, so if those reactions didn't happen, we wouldn't have any trees, no plants, and we wouldn't have any of the good stuff, starches, that make up things like potatoes, rice, French fries, potato chip, the good stuff, pizza. So think about that. Now, that also has important ramifications. Oh, one thing I should point out, once in a while, Mother Nature, instead of using the hydroxyl group here, will use the hydroxyl group here. And normally, this is considered a straight chain starch, unbranched. But if it uses here, you get a branched one. And I have it in the problem set, and I forgot to take it out for carbohydrates. Amylose is straight. Amylose pectin is branched. We use this hydroxyl group instead of the OH that was on there. And it gives different types of starches. And how many of you have heard when you cook, there's somewhat more gluten and also easier to work with, and that's what causes that. Does everybody see my slides on the screen now? All right. My computer, I think, is going haywire. Hang in there. This happened this morning. All right, unfortunately, I lost my whiteboard with the stuff on there, but I'll be able to put it up in a second. It's on the videotape too, but all right. Now, sucrose, how many of you heard on it? You don't have to, everybody see the structure of sucrose on your screen? Thank you. Is glucose and fructose bond together. This you should know. Sucrose, which is table sugar, and you should know the name of that. That's a common name, not an IUPAC name. And table sugar is even a more common name, is really a glucose bond together with fructose. Now, you don't have to know this, but this is the glucose part. And this is the fructose part. And I won't ask you to draw this ever, but you should know this, that sucrose, table sugar, is glucose and fructose bond together. And right here, this bond is an acetal-ketal linkage. So you should know, first of all, what is sucrose? It's table sugar, and it's made up of glucose and fructose linked together. That you should know. And polysaccharides, otherwise known as starches, are held together, as I just showed you, by glycosidic linkages, which is what carbohydrate chemists call it, but I'll call it acetal for glucose held together, or ketal acetal for sucrose, glucose, fructose held together. This won't be on a test, but I just want to mention it. Now, starch is a polymer of glucose. A lot of glucose molecules held together. Now, this won't be on the test. This you should know. But amylose is straight chain, where the hydroxyl group is on carbon 4. Amylose pectin is branched glucose molecule, where most of them, the hydroxyl group, and this won't be on the test or the final, is on hydroxyl group 4, but the bottom one also. All right. Now comes to the exciting part of this chapter, and that is, have you ever wondered what goes on your stomach when you eat something with a carbohydrate? I don't know if I told you this. When I was about, well, if I were in a classroom, you'd see my hand way near the floor. When I was about 2 or 3, my mother used to say, chew your food well before you swallow it or you'll choke. And guess what? Found out she wasn't lying to me. I choked one time. Oh, in case you haven't figured it out, I survived. But anyways, so when you chew your food and swallow it, chew it well before you swallow it, it goes into your stomach, and what happens? And you should know this. First of all, you should know how to describe what happens when you eat a carbohydrate. With words and a general reaction. And the words are, it's acid, hydrolysis, that's an L, of, and what's the functional group held together? It's starches, an acetal. And what's that general reaction? Well, I'll show you how you learned it for test number 2. And I'll use the symmetrical. You can have an acetal or ketal. And in your stomach, HCl, H plus, and water, and you get back the aldehyde or ketone you would have used to make that acetal plus the alcohol. Now, it just so happens in glucose, this alcohol is bonded here because this is bonded to here. And this is another glucose molecule. So first of all, you should know how to describe with words and a general reaction. You don't need this line right here. I'm just showing you what happens, how they're bonded together. But let me clean it up for you. You should know, leaving my class, how to describe with words and a general reaction what happens when you eat a carbohydrate. And here you have acid hydrolysis of an acetal, because the linkage between glucose molecules, as I just showed you, is an acetal linkage. And therefore, for a general reaction, I'll just have you remember a symmetrical acetal or ketal. Add acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that. Now, switch is on. Let's look at the following reaction. And I'm going to do something a little different. Give the structure or name the products for the following. And let's try this one. And what do? Well, what's starch? Really glucose linked together. And when you add acid and water, you break this acetal linkage and you get back glucose. And since I don't ask you to balance anything, the answer is when you eat a starch, what does your stomach make? It breaks it down to glucose. Now, if you go back and look at the slide I had a while ago, it said glucose is the most abundant sugar in nature. Why? Because that's what your body breaks down starches to. And if you're an animal, guess what? it breaks down starches too. And that happens. Now, let's do the following. I'll let you do this one. What would be the product or products for the following? Sucrose plus acid and water. And then I'll do it. Everybody keep your fingers crossed. I don't lose internet access again. You know something? I should have kept my mouth shut. Remember, give the structure or name the products or product of the following reaction. Hang in there, I gotta say something. All right, time's up. Well, what's sucrose? Sucrose is glucose linked together with a acetal-ketal linkage to fructose. And if you break this, what happens when you eat something with sugar in it? You put it in your tea, coffee, or on your cereal this morning, you get back glucose plus fructose. Now, time for Dr. White. Yeah, I've got time to talk about something that's my personal opinion, but I think I'm right. But just in case, you know, it's my personal opinion and it's worth what you paid for it. Well, you have to pay for the class, but not my personal opinion. Now, how many of you have heard in the last 8-10 years, there have been a number of mothers groups who've gotten onto food companies and other companies and saying, oh, this high fructose corn syrup, real sweet, that you put in all the things like ketchup, pop, and food my kids eat, you know, sweetened cereals, is bad because it causes various detrimental medical problems like autism. And that's because of the fructose. Now, I don't believe that part about autism. Yes, if you eat a lot of calories, you'll get overweight like Dr. White is, and that is definitely not good for your health. But it has nothing to do with the actual fructose, it's the total calories. That's my personal opinion. Well, what did the food companies do? After the cry from these mothers groups got so loud and important to their sales, they said, oh, we hear your pain, and okay, we're going to take out a lot of the fructose, and guess what? We'll replace it with sucrose. And the mother groups were happy. It's still high calorie, which is the real problem. And why is Dr. White saying that? Because in your body, the sucrose is broken down to make fructose and glucose. And guess what? You're still inducing or injecting or consuming, getting in your stomach, a lot of fructose. So, has sugar been bad for us, whether it's fructose or sucrose? And the answer for me personally is yes, but that's because of calories and making you overweight, not from, and overweight causes medical problems. I exercise a lot, so I guess I've been sort of lucky, but still, I got to lose more weight after Christmas. Maybe, no, for sure. Actually, being in the pandemic doesn't help either. Most of the people I know gain weight. You two, I've seen you guys, well, you're young and you're skinny. I hate you. No. But anyways, remember this. Now, let's do another reaction. And why don't you try this one? Same instructions, draw the structure, give the name of the product. When you react 50 glucose molecules with 50 more glucose molecules with acid catalyst. All right, I think everybody's done. And the answer is, when you link a lot of glucose together with a lot of glucose, what do you get? Starch. And by adding water and acid, you break it back down. That's how your body breaks down starch. But this is how Mother Nature makes starch from glucose in a plant. Oh, let's do one more while we're having fun. And let's look at the following. What happens when you react glucose and fructose together? In the presence of acid, which is usually an enzyme. Remember, enzymes, most, not all, are just very fancy acid catalysts Mother Nature uses for very specific molecules. And unfortunately, this class, we can't get into how that works. That would be biochemistry, which I don't teach here or anywhere. Looks like everybody's done. And the answer is, if you react glucose and fructose together, you get sucrose. Now, one of the things I taught you was that if you link a lot of glucose molecules together, you can get starch and other carbohydrates. Guess what? I've got a piece of paper, and this is made up of glucose molecules linked together. And if I were to rip this up, and no, I won't eat it, guess what? It's not going to keep me alive. How is that? Well, think about hay or grass. You go out to a farm and, ooh, that reminds me of a story long ago. I'll have to tell you in a second. And you drive by, if you're out in the countryside, you see cows eating hay or grass. They're converting it into glucose. How come they can do it? We can't. If you want, go to the zoo and look at an elephant, or go to a farm and see a horse, and they've got monster stomachs, much bigger than ours. Oh, by the way, the cute story I just remembered was one time we took a family vacation road trip. My father said, Mother, we're going to get in a car, my sisters and me. We're going to drive from Chicagoland to Niagara Falls and back. And part of the experience is driving through the countryside. Now, my younger sister, who's 7 years younger than me, I have another one who's 7 years older, Dr. White's in the middle. She was about, 5 or less, maybe 4. and we're driving through the countryside because my parents wanted us to experience that. And my sister used to say, "Oh, look at the cowls." She couldn't say cows. She used to say, "Look at the cowls." God, I still remember that, and I still haze her about that at times. Have you seen any cowls lately? But if we look at glucose, starch, turns out there's stereochemistry. If you look at a tabletop or your hand, there's a top and bottom. Well, it turns out in starch, this is a cyclic form of glucose, you can have a top or bottom. And this is called, one of these is the alpha linkage and the other beta, I always forget. When it's below on each side, and everybody can see the starch molecule on the screen? Good. This is easy to break. Hydrolysis means acid and water, and you get back glucose. This is a cyclic or Hawthorne form. Now, in cellulose, like in my paper or in grass or hay that animals will eat, here you have linkage goes from top to bottom. And turns out this is very slow to break. Well, in your stomach, there's only a certain resonance time. In other words, how long does stuff last in your stomach? Starches, it's in your stomach, and I think it's also your small intestine, but don't quote me on that. Starches can have a shorter time to break down to glucose. But if you were to eat grass or hay or paper, guess what? It's not going to be in there long enough to break down, and that's why you can't get a nutrition from that. Isn't that amazing? Now, let's look at the starch molecule here. What do we see there? You see other hydroxyl groups on carbon. Those are alcohols. Guess what? The chemistry you learned about alcohols still works on these molecules. Oops, wrong thing. Now, let me remind you of a reaction we learned a long time ago for test 2. Everybody see the alcohol on the board? Thank you. Now, if you take an alcohol and react it with 1 molecule of ethylene oxide, you get this ether alcohol, which I taught you in test number 2. Well, it turns out you can react ethylene oxide with cellulose. The cellulose is extracted from plant material. You get a lot of it when in lumber mills make sawdust. You can get it from there. There are other ways of getting it from plants too. And let's look at the following. I'm pulling up something. All right, everybody see hydroxyethyl cellulose? And if I move this out of the way, everybody see the structure over here? And this is a repeating unit of cellulose, the glucose. R can be a hydrogen alcohol, or when you react that OH with the ethylene oxide, it's CH2, CH2OH. Now this is called hydroxyethyl cellulose. It's a white solid. You put it in water and it's a thickener. It makes things real thick. Now, one of the important uses is in KY, personal hygiene jelly. And it's a personal lubricant for use for personal, how should I say, fun activities. I'll let you figure out what those are. And really, it's just water and some glycerin that's thickened with hydroxyethyl cellulose. And there are other products that use that too. Now, I've used it to make monster slime, even though you can use polyvinyl alcohol. And it's really good at making bubbles for blowing things. And this is made by that. And it's also used in cosmetics and certain products like, I don't know if they use hydroxyethyl cellulose in ketchup. By the way, switches off on hydrox. Now, everybody see cellophane on the screen? Now, cellophane is this crinkly, clear polymer. It's a polymer that is used like here, or if you buy candy that's wrapped in cellophane. And what is cellophane? Well, it turns out, and I don't know the exact chemistry, but if you take here cellulose and react with sodium hydroxide and carbon disulfide, you'll replace the hydrogen with this right here. And when you do that, it forms that crinkly polymer. How that does that, it's an area of chemistry I don't know. Now, another one, how many of you are familiar with, have you ever seen on TV or on the movies, the film they used to use before digital to record movies on? And if you went to the movie theater, they had these huge rolls with the film on there. And they run it through and they'd shine a light through that, projector it's called, and it had a soundtrack for the electronics so you could hear it. And that's how you saw the movies. Nowadays, and Dr. White hasn't been to theater in a long time, I'd say over a year, was with COVID-19. No way am I going. There's no way. I'll buy the DVD or I haven't gotten to Netflix yet, but there's a lot of other movies that are online. But back in the 20s and the 1900s through the 1930s, they made the film they recorded the movies and copied it on was a product of cellulose. And nitrocellulose, can everybody see this now? What happens is if you take the hydroxyl group on cellulose and you replace it, react it with nitric and sulfuric acid, put a nitro group on there, it's called nitrating. It's similar to how you nitrate benzene, which I taught you. You form nitrocellulose. Well, it turns out, remember when you put a lot of nitro groups on a benzene ring or toluene, you get TNT, trinitrotoluene. Well, it turns out decades later, the film used with nitrocellulose is not that stable. And it's happened where old films from the 1920s or 1910, 1925, with time and age, all of a sudden detonated or started fire. So about, I would say 1960s, 1970s, there was a major effort to all the filmed movies from 1910, 1920s. If you haven't seen Charlie Chaplin movies, the silent ones, you should. He's amazing. and there are a couple other actors those times who are just doing amazing stuff on movies. But anyways, they recorded them on more stable film or now recorded them digitally because the nitrocellulose made from cellulose, the alcohol reactant, I didn't show you that, makes a very unstable material decades later. Be careful. Now, that reminds me of something I didn't teach you, but I got a couple minutes right here. How did I mute myself? I don't know. Oh, that's how I did it. All right. The reaction to make nitrocellulose, and do never, never, never try this at home. Makes this nitro compound. By the way, if you try the following reaction, you'll probably kill yourself, so don't ever try it. I think I'm drawing the structure right on this. I'll have to look it up. Remember, nitric, sulfuric acid plus nitric acid, and the switch is totally off. And I showed you this for nitration. This is how you make a nitro group. And let me look at something real quick. I got it right, even though I haven't thought about it in ages. If you look at the whiteboard, everybody see the whiteboard right here? What I just made was nitroglycerin, which is a very dangerous explosive, as dangerous as trinitrotoluene. I don't know how they stabilize it, scenario I never would work in. I don't want to blow my face off. But in very small quantities, like very, 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 very tiny quantities, it's a good medicine for people who have heart problems. And I think you might have heard of nitroglycerin tablets, which have a very, very, very tiny amount of nitroglycerin in them. Because more than once, students have asked me over the years, how come those nitroglycerin tablets don't blow up? And I say because it's stabilized, and there's a very, very, very tiny amount of nitroglycerin. So let's go over what you learned today. First of all, remember, when you eat a carbohydrate, how do you describe with words and a general reaction what happens? What functional group is in a carbohydrate we eat? An acetal. And in your stomach, there's acid and water. You describe it with words, acid hydrolysis of an acetal. And for test number 2, you can draw both the acetal or ketal. You get back the alcohol and the aldehyde you would have, or ketone you would have used to make that. Remember, in glucose, this alcohol is bonded to this part. And speaking of that, you learn what is starch. Take a lot of glucose, react it with more glucose in presence of an acid catalyst, and you'll get starch. Now, an important disaccharide that you learned about today, if I take glucose plus fructose, acid catalyst, otherwise known as an enzyme, what do I get? Sucrose, which you should know as table sugar. By the way, next time you happen to be in the kitchen, if you see some white sugar crystals, think about it. That's just lots of fructose and glucose linked together, and that's what you're looking at. Isn't that amazing? And if you happen to take up a potato chip or two, this is what Dr. White doesn't eat. Did I tell you, besides comfort functional groups, Dr. White has comfort functional, comfort foods. You can tell I'm not skinny. No, I'm not skinny, never have been all my life. And one of the most dangerous of all comfort foods is 2 of them. One is Lay's onion and sour cream potato chips. For some reason, as soon as I open that bag, within an hour or 2, they just evaporate all the way. They disappear. I don't know what happens. I know what happens. I shove them in my mouth as fast as I can. I love them. The other one in the last couple of years I've also liked real good is Doritos. Now, I'm going to teach you something real bad. If you go to Costco, they have these monster bags of Doritos on normally just not even on sale for like $3.50 a monster bag. They're like 2 or 3 of the bags you get at the supermarket, which are the same price. And recently they've also been selling, just like I need a hole in my head, the Lay's onion and sour cream potato chips. I only buy those 2 or 3 times a year, maybe 4. One is my birthday, one is New Year's, one is the Super Bowl, and one is when we have election night, and it's harrowing and you need comfort food. So, now, what should you also know? If you put some sugar on your Captain Crunch, which is just more sugar, I haven't had that in decades. Anybody Captain Crunch people? That's like sugar on sugar on sugar and a little starch to put it in there to say, oh, it might be healthy for you. You should know, you add sucrose and you add acid and water. Where do you get this? Your stomach. And it breaks it down to glucose plus fructose. Yeah. And finally, If you had potato chips or French fries, I haven't had French fries in ages because I need those like a hole in the head too. And with the pandemic, I don't go, but if you had French fries or potato chips or a potato, that I do eat, potatoes and rice, because they're healthy for you, and you chew it before you swallow it or you'll choke, like my mother taught me, and I found out she wasn't lying to me. What do you get? You get glucose. And if you ever go to a hospital, if you're working as a nurse, and I learned this from years ago when I had a nurse in my class who was going back for her master's, they had to take organic again because it's been so long since she had organic. We talked about this, and we were talking about this chapter. She said, you know, the stuff we use for intravenous feeding is this D-glucose and water in a bottle, because that's what's the sugar that your blood transports. In your blood, it transports glucose to the different cells to do whatever it does. Now, Dr. White doesn't know biology, so if anybody knows what it does, let me know later on. And that's what you get. Boy, we had a busy day today. Now, the next time you eat something with starch or something like that, I've just ruined your dinner, because now you know what chemical reactions are. By the way, don't tell people at dinner, you know, when you eat that, you'll be converting the starch to glucose via acid hydrolysis and acetal. People don't like hearing chemistry during dinner, especially dinner parties. They do not like that. So don't. And with that, I'm looking at the clock, and you know what? I'm going to let you out a couple minutes early. Remember, Wednesday, we will have a lecture, and I'll go through the lab. Make sure if you're behind in labs, let's get them in soon. If you need my help, let me know. And also, be safe out there. It's getting nasty. Gang is on. Be healthy. With that, one more thing. Remember, tonight I'll have my office hours. And since after 5 p.m., there's no class at ECC, so you don't feel cheated. Tomorrow night, if you need me, I'll be here for my office hours at 6 to 7:15 at the normal Zoom. Oh, I get to do this twice. Goodbye. Gang is on. Be healthy. I'll see you tomorrow. Pray for my internet.